Hello, my name is Peyton, and we'll be doing standard C3 today. The standard question is explain how mixtures can be separated by using the properties of the substances from which they are made, such as particle size, density, solubility, and boiling point. A mixture is a combination of two or more substances that have not been combined chemically. An example of a mixture is chocolate chips and ice cream. One type of mixture is known as a solution.
A solution is a mixture that looks the same from everywhere. An example of a solution is table salt dissolving in water. Mixtures can be separated into their individual parts by using techniques based on their physical properties. Particles can be separated by their size. Some examples of mixtures being separated is iron being separated from wood shavings by a magnet. A strainer or sieve can be used to separate large objects from smaller ones.
In a solution, one or more substances are dissolved in another. The substance that is dissolved is called the solute, and the substance that it is dissolved into is called the solvent.
Soluble or insoluble substances can easily be separated by filtering and filtration. This is because the insoluble particles tend to clump together, forming larger sized particles, while those remaining in solutions Soluble and insoluble substances can easily be separated by filtering and filtration. This is because the insoluble particles tend to clump together, forming larger sized particles, while those remaining in solutions remain separated and are much smaller. A tea bag or coffee filter is a good example.
Solubility is not limited to solids and liquids. Gases can also dissolve in water to form solutions. Soda is a solution of carbon dioxide, or CO2, in sugar water with a little added flavor.
The boiling point of a substance is the temperature at which the liquid turns into a gas. A solution of two liquids, say rubbing alcohol and water, can be separated by the differences in their boiling points and in a process called distillation. And that is it for Standard 3, and we'll see you guys next time.
Peace! Welcome back. I'm back again with the Science CMT. We got C number 5. And C number 5 was explain how populations are affected by predator-prey relationships. And populations are affected by predator-prey relationships because by food webs, actually. Sorry. For example, if predators eat way too much of their prey, they can become extinct. The prey become extinct, and then without their prey, the predators will have no food to eat, and they will eventually die out. Then another example is if the predators just die out or because of diseases or something, then the prey will overpopulate and basically destroy the ecosystem. Which is bad. Very bad.
Hello, my name is Peyton, and this is Adrian, and today we're going to do standard C21. And the standard question is, describe how freezing, dehydration, pickling, and irradiation prevents food from spoiling by microbes.
Most foods are chemically quite stable. Spoilage only occurs when microscopic organisms, bacteria, yeast, or mold grow on them, producing toxins and decomposing foods.
Food can be preserved in many different ways, but all methods either kill the bacteria or slow down its reproducing system.
One way to preserve food is changing the temperature. At room temperature is 22 degrees. Many foods spoil quite rapidly, but when put in a refrigerator, it can remain fresh for many days. This is because the temperature of the fridge is cold enough to stop or greatly slow down the growth of bacteria.
Freezing is an even better way to preserve food from spoiling. When bacteria is frozen, it is usually destroyed. This is because the initial formation of the crystals in the cell can destroy the structure of the cell.
Heating some foods will also preserve them in the process of pasteurization. Some foods that can be pasteurized are dairy products, beer, and wine.
Another way to preserve food is dehydration. This is the process of removing water. Like all other life forms, bacteria needs water to survive. Dehydration is usually used for fruits and meats. Some examples are beef jerky, salted fish, raisins, and apricots.
Pickling is the process of storing food in a solution of vinegar. This prevents the bacteria from growing and reproducing, especially in the absence of air. Pickling is often used for meat, eggs, and vegetables. Examples include cucumbers, onions, and sauerkraut.
That's all we have. See you back here for C30.
Yeah. Oh. Hello. Sorry for the delay. This is for standard C30, and the standard question is: explain how beam, truss, and suspension bridges are designed to withstand the forces that act on them.
Bridges are elevated structures used to transport objects between 2 points. The total net force is a combination of individual forces. When forces are going in the same directions, they are added together, while opposite forces are subtracted. When the net force is at 0, all forces are in balance. Bridges have to support its own weight plus the forces of those objects crossing over or on the bridges, such as ice, snow, and wind.
In a bridge, the load force is in balance with supporting force of the structure. The two most important forces acting on bridges are compression and tension. The design of the bridge structure determines how these two forces are distributed. The simplest type of bridge is a beam bridge. A beam bridge is a long, narrow deck supported at each end by the ground or a pier. Too much force on top of the bridge will cause it to break. Since the forces cannot be transferred away from the span, beam bridges are used only for short distances.
A truss bridge uses a series of interlocking triangles to support a flat span. When a load is on the bridge, the forces are distributed over the entire network of the triangles, giving a bridge extra support. An arch bridge has each piece. On an arch bridge, each piece of the arch is supported by the pieces below it. The supports push back, preventing the ends of the bridge from moving apart and keeping the bridge stable.
In suspension bridge, heavy cables are strung through towers and are anchored into the ground at each end of the bridge. The deck is suspended from the cables. The load presses down on the deck, but the compression force is transferred into the cables and eventually into the towers and the ground. This makes the suspension bridge the best type to cover large distances. And that's what we have for C30. And thank you all for coming. And my special salute to you guys. Dab. Bye.
Welcome back, it's Miles here, ready for the CMT Science with C number 23. Yeah, right, JT?
Yeah.
And C number 23 is describe the qualitative relationship among force, mass, and changes in motion. Yeah. And inertia is the tendency of an object to resist a change in motion. According to Newton's first law of motion, an object at rest will remain at rest, and an object in motion will remain in motion at the same rate of speed and distance unless acted upon by another unbalanced force. Never mind. 3 terms are needed to understand motion. Speed is the distance traveled by an object over a specific time. For speed, acceleration needs to happen. Acceleration is the motion or the movement of before speed. An object accelerates into speed. And distance, the last term, is how far you're going, basically. Yeah, that's it for us.
Hello. My name is Adrian, and this is for Standard C12, and the standard question is, explain the relationship among force, distance, and work, and use the relationship work equals force times distance to calculate work done in lifting heavy objects.
A force, F, can be defined as a push or a pull. Work, W, occurs when force moves an object over a distance. These things are mathematically related by the equation work equals force times distance.
To do the same amount of work, there needs to be a large force over a short distance or a smaller force over a greater distance. An example of a large force being used over a short distance compared to a smaller force over a long distance is, say, you were loading boxes into a truck. There is one ramp that is very steep and short, and there is another ramp that is longer and steep.
Which one is better? I'll give you a second to think about it. If you said the first ramp, you were wrong. The second ramp is better because it is less steep and it is easier to push the box up the ramp.
So, the less force, the greater the distance over which the forces was exerted.
Exactly.
Oh, and thank you for your time. And
We're cutting this.
Okay.
Welcome back to me doing our CMT for science. Yeah. Right, JT?
Yes.
And our sync was sync number 2, and it is read, intercept, and examine the credibility of scientific claims in different types of resources. When you're looking for different types of scientific claims, you have to use different types of resources. For example, first, you have to read carefully if it is good quality information. Next, you have to interpret and examine the credibility of scientific claims. Then, if you have to write it down, write it in your own words. Because if you write it and you copy it, it's bad, and that's plagiarism, and then you can get arrested, which is very bad. Right, JT?
Yes.
Exactly. Welcome back. I'm here. My name is Miles, right here with JT. Right, JT?
Yes.
And then, we're here with CMT. What was CMT for science? Yep. We got C number 14, which is describe how different types of stored energy can be used to make objects move. Well, different types of stored energy can be used to make objects move. For example, when energy is stored, it is called potential energy. When the object starts moving, it's kinetic energy. Also, energy can be stored in electrical bonds and can be converted to kinetic energy in all animals and plants.